Hey guys, welcome back. On today's show, we have, and this is all bent in right here. So it's been welded before. This is all pushed in. We're gonna replace this entire top piece with something a little bit thicker than, I don't know, what is this right now, maybe 1/8 inch. We're gonna do 3/16 or quarter. Probably gonna end up rebending these tubes. I'm thinking we're gonna leave this part alone. We'll just tie that back in. So just kind of cut that off there. All of that is gonna get remade. For sure this, I'm not sure if these are gonna get remade yet or not. We gotta get the motor off and kind of inspect this a little better. So we're gonna pull the outboard off and then we'll be able to investigate a little bit further here. Okay, we got the motor off and we just set it in the boat. No sense in having to disconnect everything. All we had to disconnect was the fuel line. So we just set it in there, got her strapped in, shouldn't go anywhere. I guess you're probably wondering what kind of boat this is. This is for California National Park. And this is their outhouse boat, pumper boat. So you got the outhouses on the lake. This is the boat that goes out there and sucks out all the waste in the outhouse. As you can see, they take great care of it. Look, it looks fantastic. The gentleman also told me they went through 3 propellers in the last 45 days. So I don't know what's up with that, but so after looking at this, I think we are going to probably just going to rebuild all of this except for this. I think we'll leave that, and we're going to cut all this off and rebuild this entire section, this whole centerpiece, and we'll probably reinforce it a little differently. All right. All right, so we got this transom all cut off here. Plasma made short work of that. See kind of how, I think that'd be a little thinner, or a little bit thicker for a 225 horse motor. That's kind of how they did it. See the failure points right on the edge of those pieces of channel. All right, now we're going to plasma gouge those off, and then we'll get that all sanded down and ready to accept new material. So a pretty common thing I do for protecting air lines, hydraulic lines, whatever, is I use just regular cotton towels and I soak them in water. And that seems to work really well to protect from slag and whatnot. And if it's like an extreme case, I'll do that, and then I'll wrap it with a fire blanket, like a fiberglass blanket, or maybe even further than that. But something like this, just a wet cotton towel, it'd be perfect. Just like in a lot of my videos, we're going to be using 3M Cubitron with WD-40. That way the wheel doesn't load up on it. All right, we got her all sanded down, and upon sanding, we have some cracks going all the way through that piece there and there. I'm fairly certain that will allow water to get into the boat. I'm gonna have to get inside there and see if I can pull some panels up or something and see if I can maybe see those from the inside. But now we have that all smoothed out with the Cubitron. Now we're gonna use 3M backing pad, and not sure the technical name for these, Brillo pads or Scotch Brite pad. We're gonna use these, and I'm gonna clean the whole back of the boat with it as much as I can, just to kind of clean all the oxidation off there, because we are going to be putting some extra gussets and stuff in here, and I'm not exactly sure where all my material is going to sit. So we're just going to clean it all and make it all nice and shiny. All right, we got the back cleaned off pretty good. So now we're going to work on measuring everything out, making sure we order the right amount of material and all that. So we're going to get all the material ordered, have all that within a couple days, hopefully, and then we'll get back on this thing. All right, here's something I haven't showed you yet. This is where I get all my laser cutting and forming done. This is for the boat, obviously. Here's aluminum I got cut. I'll take you in here and show you a little bit of what they got going on. Here's our piece that we cut off, and you'll see how we're going to remake it. We got 2 lasers, cut out all kinds of different parts, whatever they need. We got 2 press brakes, All right, we got all the pieces back at the shop. We got all the edges deburred and everything. And then we kind of started fitting these together. You can see how that is going to leave a real nice fillet weld there. Still have to tackle these cracks. We're going to drill holes on each end and weld it from the inside and the outside. And then you can see our top plate. Still got to deburr that and kind of massage that into place. But we're going to work on tacking all this together first. And then because that piece will just slip on the top when we're done. So now we're going to work on, we have to notch these out a little bit, kind of get these side pieces on. All right, so we've got this transom box all tacked together here. Now this right here, this was gonna be like a nice circle. Well, the laser decided it didn't want to cut the circle and, you know, kind of running behind on this, so we just had to get it done. So we decided to cut a square out, and then we're just gonna use this piece to go back in there. We're gonna cut some pieces that overlap it, and then those will have threaded holes, and then we'll use these stainless countersunk Allen bolts, and they'll go through that piece into that, so everything will be flush on the bottom, just in case they, you know, run through some branches or who knows what. Nothing can really get in there and get caught. And then the main reason you even need a hole here is to access the two lower bolts to bolt the motor on, because the two top bolts you can get to both sides, and then the bottom ones, you all have to stick your hand up from underneath to put a bolt, a nut, and a wrench on it. So now we're gonna do those cracks, and then we're probably gonna check fitment of that on there with the top piece, and then we're gonna weld this out on the table, or do as much welding as I can on the table, and then we'll put it on there for the final time. Okay, so we got a hole drilled on each end of the crack, and then we've got it ground out about, I don't know, 80% or so. So we're gonna weld this side, and then I am just able to get to the other side. It's gonna be a real uncomfortable position, but I'll be able to clean the other side and then burn back through into that. And then you can kind of see like that line there, here, so there's, and then the obvious plug weld, so there's like a reinforcement behind this, so that's really going to help with our new pieces, because our new pieces are significantly thicker than the old one. I'll go over that in a little bit, but so all that reinforcing behind there is good. It's not just like a 1/4-inch plate and then we're welding all this stuff to a 1/4-inch plate with nothing on it, because it might appear to be that way. There you go. No more cracks. All right, now we're gonna focus on getting this sucker welded out. And then to weld this piece out, using our Miller 251, you got 21.7 volts. And then this is how you adjust the wire speed right here. So it's about 7 1/4 or so. And then those of you that don't know, this is called a spool gun. And then your wire sits in there, goes right through a set of rollers and straight out into the weld. The reason for this is the aluminum is very soft. So that little thin wire, if you tried to feed it through that lead like you would normally use, it would just get all bunched up and just you would constantly be having issues. So that's why they invented the spool gun, and I like using the spool gun for aluminum. It works out really well. And this entire boat was welded together with the spool gun, so we're just going to keep that same process here. All right, let's get to welding. right, we got our plate on here. Let's see, we got our countersunk bolts, stainless bolts, into the plate on the bottom. Perfect. Now we can put this sucker on there. All right, so we got, this is just tacked on. This is just sitting on there. We do have an issue. It's one of those things you run into when we changed this to 3 brakes instead of a long sweeping tube. I guess there was no real particular reason. It's just what we did. So now we have another issue. This does not line up. So we're going to think of a creative way to make that area work and look good. All right, so after a lot of thinking on what to do here, remaking this is not an option due to time restrictions. So I had this piece somehow. So it's a little bit bigger than what we need. So I'm going to fit this piece in there to where it kind of curves up and runs into it here. Thought about a lot of different options of just completely removing these altogether and then going straight across or straight in. There's lots of different options. I think the main reason these are here was because the other one was real flimsy. The old one was 1/8 inch, this is 1/4 inch, and it's got those brook edges. This is super, super stiff compared to the other one. Way more rigid. So that's what we're gonna do with the tube. So we're gonna pull this off, and then we're gonna blend these welds here, and then this weld here that's gonna be visible, and then probably that weld, I'm gonna TIG weld all that. And then these, we're gonna TIG weld these two. All right, so we got the TIG welder that I'm gonna be using all set up. I'm gonna be using the Multimatic 220 AC/DC. This is the one I usually keep in the Kenworth. We're gonna be using this one over that one because we get 210 amps of AC power versus 180, and that is a dinosaur machine. Getting there draws a ton of power and will constantly trip my 50 amp breaker. This machine will not. And I like the way that it welds. All right, now I'm going to break those tacks. We're gonna pull this off, set it on the table. We're gonna blend all this, and then we'll stick it back up there, get this welded out. Then we're gonna set the motor on there, mark our holes where they're gonna get drilled. And then because this is double wall, it probably doesn't need it, but we're gonna put some sleeves in there where the bolts go. So that way when it's tightened down, it's pinching the sleeve, and the aluminum the walls can't flex like that, because aluminum flexing will break. This is already 100 times stronger than it was, but we're gonna make sure that this lasts, 100 years at least. Okay. Move that out of the way, put that on the table. All right, I'm gonna get this all blended out. Took about 3 hours. Sanding, blending. I cut it with Cubitron first. Kind of got some of the marks out with the flap wheel, then blended it, finished with that. I don't think it needs to go any further than that. Looks pretty good. All right, now we're going to put that back up here. Well, we're gonna clean where the welds are gonna go. Then we're gonna put that back up here. Some of you may not know, aluminum actually does rust. It oxidizes, and it's kind of a clear oxide. And obviously, perfect example is that's, you know, oxidizing. Even though this was sanded down just the other day, that now has a thin layer of oxidation on it. So technically, you should sand that off or brush it off right before you're ready to weld. Ideally, that's what would be done. So we'll hit that real quick, and then we'll get that tacked on. Perfect. All right. Now we're going to just double, triple check that's in the right spot. And then we're going to weld this out. Weld it outside, inside, everywhere I can get. It did not have a piece here originally, so it'll have all that extra piece kind of pushing. Just it'll have a real big surface area pushing against the bottom and pulling on the top compared to how it was. You know, just weld everything in here. So after we get this welded, then we're gonna pull it outside, use the crane, set the motor on there to get our holes. Three passes. I don't think it's going to go anywhere. You can get welded on the inside as well. All right, now we'll repeat the process on the other side. All right, got it all welded. All right, now it's time to set the motor on there and get our hole position. All right, so we set the motor on there. And we got our holes. I was able to use a drill bit, a tight fitting drill bit on the top holes to get my exact center. Couldn't get them in the bottom. The bottom hole has a slot, so I was able to scratch it with a scribe. So I have those marks. So now we're gonna drill through, maintaining 90 degrees to this face, drill all the way through. And then we have some 1.5 inches here. We're going to drill slightly bigger than a 1/2 inch hole. I'm not sure what bit I have yet. We'll drill a hole through that. We got a 1/2 inch hole saw. So we will hole saw this out. Probably have to come back on this side to hole saw that side. And then we will put a taper on the bar. And then the bar will be the same thickness as the outside faces. That way it's pinching it when it gets bolted down. So you'll see what I'm talking about when we get a little further into it. All right, now we're gonna do the same thing to the other 3 holes. All right, so we got all of our spacers or whatever cut, beveled here. All right, now we're gonna put them in there. I did think of course, after drilling the holes, I did think of a flaw in my design here. And that is drilling holes through both sides. Should have left one side with just a 1/2 inch hole and then slid this in and butt it up against the inside of that. That way it will pinch it. Basically what I'm getting at is the washer is only that big. So it's gonna be pulling on that, and it's gonna be pulling on that weld right there versus pulling on this entire piece. So we're gonna either make washers, bigger washers, or I have some stainless flat bar I will put across all the way. That way it's not pulling on just those, it's pulling on the entire thing. So did make a mistake on that, but it's easy fix. All right, now we'll get these welded in. All right, got those welded out. Now we'll sand them flat. And on to the next step. All right, got her all blended. Pretty close. Now we can put the top on and get all that. Make sure it's all fitting correctly, and then start welding that out. Looks pretty good like that. All right. There's a little bit of massaging we have to do here. At the top of this is going to follow that line. So we just got to kind of push and twist a little bit and get it to sit just right, and then we'll start TIG welding it out. All right, we've got that top piece tacked into place. Now we're going to deal with this situation. All right, I've played with this thing for, I don't know, like 2 hours. This is what I like the most of everything that I've done. It doesn't match that side, but I kind of can't really, I don't know. I don't like it, but it is what it is. I was originally going to try to do something like under it, like that, but that didn't seem to work right. I think that kind of carries the line of the tube. I mean, if they completely hate it, then I'll change it. But I know they need this thing back, so we're trying to get it back to them. All right, now I think the only thing that's left is start stacking some dimes on here. All right, got those welded out. Probably gonna be more of the difficult bigger gap, kind of a weird angle. Weld this out, and then, I don't know, just keep plugging away. The thing with aluminum is it gets hot. Aluminum like just soaks up the heat. That's why you need like a ton of amps just to get it hot enough to even like start your puddle. So we might preheat a little bit of that area just to kind of take out that initial heat input that is needed. So if you like preheat it, it just really helps with getting the bead started and going. When you have a smaller machine, this one's only 210 amps, and we had like a 400 amp Dynasty or something, this would be just, it'd blow right through this like nothing. All right, let's weld this out. All right, we're just gonna keep plugging away at this thing. All right, got her all welded. Doesn't look too bad. All right, now I'm gonna call it a day. Try to figure out how to kind of blend some of this in so it doesn't look as crazy. I was gonna sandblast like the whole bottom area, but I think I might just wire wheel it with a stainless brush on a grinder. I think that might blend it in pretty good. So we'll probably do that, and then we'll bolt the motor on. But right now, that's it. All right, well, that's it. This project is done. Motor's installed, everything is all put back. Cracks are welded on the inside. She is good to go. All right, you can see the old one. You can see this is 1/8 inch, 1/8 inch, 1/4 inch, 1/4 inch for these, and then whatever those 1/8 inch tubes are. We've got 1/4 inch, 3/8, double wall with sleeves, all tied in. Significantly better than this one. The main failure point was there, and down here buckling. Definitely not going to have that because ours goes all the way down. And then you can see our nice cover on there. Keep all the debris out. Should be perfect. All right, well, that's it for this video. Thank you for watching. Stay tuned for the next one.